Hi, my name is Muhammad Nur Hakimi bin Maslan, and I am a chemical engineering student currently studying at Universiti Teknologi Petronas. This is a video about our integrated project, explaining about the contents and tasks required by the courses that involved in our project. My team members consist of my batch mates, includes myself, Sarenya Balendrasan, Lim Xiao Tong, Udra Firdaus bin Izha, and lastly Ahmad our TD. Let's proceed to the content explained by Sarenya and Lim Xiao Tong.
For the first part of the project, we have to design a membrane separation process system for the removal of contaminants from the raw natural gas in stage 1. This is for separation process 2. In this, raw natural gas consists of carbon dioxide, methane, H2S, and water vapor. Let's look into the objective of the project. First is to design a membrane separation process system for the removal of contaminant as said as before, and to design and develop a membrane separation unit which includes material, type configuration, size and dimension which are required, and to study to observe the calculations that are related to this membrane separation process with the justification. The membrane that we have chosen is a polyimide membrane, which shows great selectivity and efficiency in gas separation. So this selectivity for this membrane CO2 over CH4 is 60 barrier, and the CO2 will be removed in the permeate stream while CH4 will be in the retentate stream. So this membrane thickness is about 50 to 100 micrometer. Gas separation process in the industry, there are actually two types of membranes which are usually used, which is hollow fiber membrane and spiral wound membrane. Why so? Because of the less energy consumption and it can be found in a lower cost. For our group, we have choose hollow fiber membrane to use in our separation process. Why? Because this hollow fiber membrane can withstand extreme pressure and temperature, and it also contains high tolerance of high hydrocarbon content in the natural gas. And according to some membrane manufacturers, they say that this membrane increases the recovery of CH4, which is methane.
The assumption for our membrane is the amount of hydrogen sulfide and water vapor in the membrane units are too small, so the H2S and the H2O that move into the membrane unit is considered as negligible and all flow into the retentate stream. Next, no heat loss to the surrounding. Isobaric system is assumed. The membrane unit is complete mixing model, and the next assumption is the operating condition at membrane unit is constant. The ideal gas is said to be truth and no condensation of gas. For the block diagram, the natural gas will flow into the compressor where it limits the temperature and pressure of the natural gas. Next, the natural gas will move into the dehydration unit where water vapor is being removed from here. In this dehydration, a type of liquid dehydrator will remove the water vapor from the gas stream. Next, it will move into the absorption unit. Here, H2S will be removed from the absorber with a liquid called as liquid diethylite glycol. After the H2S and CO2 has been removed, the natural gas is then moved into the membrane unit, and we consider as the H2S and H2O is being relatively small, so only HO2 will be go into the permeate stream and CH4 will be retained out. For the dimension of our membrane, the total surface that we calculated is 367192871 meter square, and for our fiber we use 6 meter as our length, 0.25 millimeter in our inner diameter, and our outer diameter is 0.55 meter. For our hollow fiber membranes, the feed will flow into the hollow fiber membrane, the rejected residue will flow out, and the permeate residue will flow down.
Now, I will explain the content from the reaction engineering 1 course part. This part is handled by me myself and Huda Fidaus as well. So this is the objective that we are trying to achieve in this part, which is to design a catalytic reactor system, whether it is a single or multiple reactor, and find the suitable catalyst for the reaction. Next, to find the strategy to maximize the selectivity of the reaction and yield of the final product. And lastly, they calculate the weight and volume of the catalyst inside the reactor. So the type of process that we have decided for our reactor is steam methane reforming process. This process is commonly applied in the industry to produce hydrogen. This process could lead to two reactions, which is reaction 1 produces carbon monoxide and hydrogen, while reaction 2 produces carbon dioxide and hydrogen. However, we will only choose reaction 1 as our main reaction, as reaction 1 produces more hydrogen compared to reaction 2, which only produces little amount of carbon dioxide and hydrogen only. So therefore, reaction 2 is considered negligible. The next content is reaction design, which will be explained by Huda Fidaus.
The design of the reactor. We have used packed bed reactor as our main reactor for our chemical reaction, which is steam methane reaction. We have agreed that we must use the volume of this reactor, which is 0.1028 meter cube. Weight of catalyst is 0.22983 kilogram. The length is 2.15 meter. The diameter is 0.03 meter. The height of our reactor is 0.1017 meter. Meanwhile, the catalyst type is heterogeneous, and the catalyst that we use in our chemical process is nickel alumina. This is the block diagrams for reaction engineering part. First, we obtain methane from the membrane separator part, and we mix it with water steam and transfer it into a heater. A heater then will elevate our reactant temperature level and set it to PBR reactor. The PBR reactor will have a heterogeneous catalytic reaction and yield carbon monoxide and hydrogen as our main product and set it into a cooler. The cooler then will reduce our temperature so that the carbon monoxide and hydrogen can be used in other part of the plant. This is the formula that we use for PBR reactor. dx over W equals to negative RA over Fn0. We will derive this equation so that we can get it into our integral form, and eventually we will get the weight of our catalyst and the volume of our reactor. These two properties is necessary to determine our design of reactor in our process. Thank you. And let's move on to the next part.
Assalamu alaikum everyone, my name is Ahmed from Chemical Engineering Department. Today I'm going to explain about this simulation part. So to simulate the steam methane reforming, we need to do several steps. So first we need to add the components that shown in the picture: methane, H2O, CO, and the hydrogen. And then we need to add the fluid package as being Robinson, since our production is in a gas phase. And then we go on to the reactions, and then we add the heterogeneous catalytic for the reaction set, and then we put all the parameters that we got from the reaction part. For example, the stoichiometry and the value of A, E, and the key, and then we add all the components there, and then we set all the forward order until we add we add it to the fluid package, and then we get the results. So we have here PPR and the mixer, and then we add all the inlet and outlet of streams, pressure and temperature, and the flow rate, and then we got the reactor product. So finally, we need to go to the case study to analyze the pressure and temperature and the flow rate, and then we study the effect of them. And then we will explain the evaluation of them in methodology part. Thank you.